All right, the couple feels pretty confident after making the first two brothers appeased by finding the formulas. They know what they're looking for, and they know the formula that they need to use is a area of a regular polygon equals 1/2 times the apothem times the perimeter, or A equals 1/2 a p. All right, that is the key. Now, what is A? A is the apothem. We already know from what we looked at before that the apothem is drawn from the middle, the center, in an equilateral triangle. That word center is really loaded because you could be talking about lots of centers to the midpoint of the side. More importantly, that red line segment, which is going to be the apothem eventually, meets at a right angle. Even more importantly to that, if we draw the radius, AD, to the vertex A, it's still a right angle here. We know that that's a 60-degree angle there, and that the radii have to bisect that particular angle. So now we have a 30, 60, 90 right triangle. Now, I had a 30, 60, 90 right triangle. Okay, when the Diamond Brothers heard 30, 60, 90 right triangle, they exchanged furtive glances to each other. The mother looked nervous about that, but the father was worried about mainly just getting the formula done so they would help them find their daughter. Okay? If you remember your right triangle and your special right triangle theorems, which basically says the short leg is the x leg, the long leg is the x root 3 leg, and the hypotenuse is the 2x leg, or 2x side. Okay? After we get past remembering a formula they should know, then it's really just simple algebra. Okay? Reduce the size of some of this text now that we know what everything's about, so we can read stuff. Okay, to find the apothem, we're going to take the ratio, side over 2, and set it equal to the expression that contains x. X in this case is the apothem. Okay, to solve this, I've basically created a proportion. Then we cross multiply. I know you could have gotten there faster just by multiplying by root 3. Some people just don't get that, so I took the long way. You divide both sides by 2 root 3. Now, I did not simplify it initially, but it can be simplified by multiplying by root 3 over root 3 to be side root 3 over 6. I'm going to assume that people didn't do that because the process of simplification sometimes causes a mistake. All right, now, I know the formula for the area of a regular polygon, including equilateral triangles, is 1/2 the apothem times the perimeter. Okay, the perimeter for an equilateral triangle is pretty easy. The perimeter is 3 times the side length. Okay, so we've got the perimeter is 3 times the side length. And really, from this point on, it's an exercise in algebra. Okay, so we make them multiply by 1/2 times side over 2 root 3 times 3 times the side. You simplify the numerator, you get 3 side squared. You simplify the denominator, you get 4 root 3. Okay, now, I could stop there. It wouldn't be completely simplified, and I wouldn't be able to prove to the Diamond Brothers that we had the same formula, so I have to do what they call rationalize the denominator. And to rationalize this denominator, we should multiply by the same radical that's in the denominator, root 3 over root 3. That's really a fancy way to multiply by 1. We do that, we're going to get 3 times the side squared root 3 over 12. And then the 3 and the 12 simplify to give you 1 and 4. And lo and behold, the final of the 3 formulas for the area of an equilateral triangle has been proven using every method, but I believe the SAS triangle area formula. When I say when the father says the SAS triangle area formula, once again, the Diamond Brothers start to look at each other nervously side to side.